This is, let's work a couple. This is my math lab 3.7. Yeah, we could do that. Question number 4. And, well, I say unfortunately. It's recording right now. Yeah. So this is a multiple choice, which means how does my math lab want the answer? When I'm going to make your next test, there will be some multiple choice, but I'm going to make them this time. Okay, meaning that you're going to see here where I would have said I would have stopped. All right, so find dy dx of 5xy plus 3 squared equals 10y. Now, of course, your next test, you're going to know implicit differentiation because it's chapter 3. When it comes to the final exam and you have like 400 questions, let's go with 500 questions, you're going to have to recognize that, oh, I have more than one variable, so that's when I use implicit differentiation. Again, my way is I say take the derivative of the outside, meaning bring that 2 down. I'm going to put that 1 there because some of you, I see if that was like a 4, you keep forgetting to put the exponent back there. So I'm subtracting 1 and then times the derivative of the inside. Now the derivative of 5x times y is a product. So I'm going to leave the 5x alone times the derivative of y, which is 1 dy dx, because this is implicit, plus leave the y alone, and the derivative of 5x would be 5, so I would have 5y, and then the derivative of 10y is 10 dy dx. So once again, for those of you that don't like my way, this is u equals 5xy plus 3, and y equals u squared, and y prime equals 2u. That's 2u, and that's u prime. So I'm doing the same thing, I'm just not writing all that over there. And so now what I would do is I would take this entire piece and multiply it by that. Take this entire piece and multiply it by that. So I'm going to end up with 10x dy dx 5xy plus 3 plus 10y 5x plus 3 equals 10 dy dx. So that's all I did was distribute that 2 5xy plus 3 times everything inside the parentheses. And now we have said we want to get all the dy dx's on one side and all the not dy dx's on the other side. So 10x dy dx 5xy plus 3. I'm chunking this one over here and chunking that one over there. So minus 10 dy dx equals minus 10y 5. Did I lose a y somewhere? 5xy plus 3. So all I'm doing is getting my dy dx's on the same side. So now I can factor out dy dx. I end up with 10x 5xy plus 3. Keep not wanting to write that y for some reason. Minus 10 equals minus 10y times 5xy plus 3. So that's all I did was factor out the dy dx, that piece, because that's what I'm solving for. And so now I'm pretty much done. I just divide both sides by all that junk I don't feel like writing again. Dy dx equals minus 10y times, bunch of sickly people in here, I tell you, over.
Cindy, I'm just focused.
I was going to say, don't you even thinking about shushing anybody for coughing. 5xy plus 3 minus 10. Now, this is where we go back, in my other class, happened that we go back to fraction land. this is a side note, you don't need to write this down. If I had 2 over 2 plus 4, I could do this, right? I could factor out a 2 out of every one of those, and I'd end up with 1 over 3. If I just flat out added that, 2 over 6, which is 1 over 3. What I'm trying to show you is over here, I can factor out a 10, but I have to do it in every single piece. Okay, so that was just kind of something forgotten by my other class. And so dy dx equals minus y 5xy plus 3. You cannot cancel that with this 5xy plus 3 on the bottom, unless of course you separated these, and you don't want to do that because of that minus 1 there. The minus 1 came from, I factored that out. In a perfect world, I'm done, but you live in the MyMathLab world. So you look at the multiple choice and there's things that are squared, so it says, well, that kind of makes sense. I'm going to throw, remember with a fraction, negative 1/2 is the same thing as 1 over negative 2, which is the same thing as the whole fraction's negative. So I'm just going to throw this negative out front for now. I ain't going to worry about it. And then what I'm going to do is I'm going to multiply, distribute the x, the y on the top, and then the x on the bottom. So I'm going to end up with 5xy squared plus 3 all over 5x squared y plus 3. That's there. 3x minus 1. I'm not distributing that x because that doesn't belong there. Okay? And once again, in a perfect world, you're done. Not in MyMathLab's world. What it did next, which is kind of weird, is it moved the negative to the bottom and distributed it. And that's why I said over here, that's okay. I don't know why. I never understand why MyMathLab does the things it does. So the final answer ends up being this. And once again, I cannot verify and say, if you put it like that, would MyMathLab count it right? I don't know. Just the person that we worked this out together had that and said, MyMathLab said that was the final answer. And so we just tried to figure out how MyMathLab got it, and that's what we did. Okay, so I'm going to do another one, and it kind of works the same way. It's just long. And again, we finished 3.7, so I really hope if you're not done with 3.7, you get done with it here pretty fast. All right, so this is I wish it was MyMathLab and I'd be pretty rich off all the dollars you guys are spending on it. This is question number 9, and unfortunately, again, a multiple choice. But this is kind of a nice one because it's got all kinds of product rules and chain rules, so it's worth, but it kind of works the same exact way. Let me know if I see some of you still writing on that other one if I go too high. So dy dx x sine 4x plus 7y equals y cosine of x. You should be getting to the point now on these where you say, you just look at it. And then you stare at it, and then you cry a little bit, and then you pray a little bit, but we ain't supposed to pray in school, so please don't pray. So first thing I see is a product rule. I see a product there, and I see a product there. I also notice inside here, I'm going to see a chain rule. And I just kind of look at that to remind me as I'm doing the problem, please don't forget to do that, okay? So, again, whatever order you go in, dy dx, I'm going to leave the x alone, so I'm doing this first product. I'm going to take the derivative of the outside of the sine, which is cosine, leave the inside alone, times the derivative of the inside. Okay, so the derivative of the inside of 4x would just be 4. And then, what happened? Why do I keep forgetting y's? Why do I keep forgetting y's? And so maybe I don't like y's. Plus the derivative of 7y would be 7 dy dx, because we're doing this with respect to x, so this is implicit differentiation. Plus the derivative of x, which is just 1, so I'm going to go ahead and put it there. Leave the sign alone. Y. And I'm done with that product. Now I got to do the product, so I'm going to have to do another line. Equals, and now I'm going to do the product rule on the right-hand side, which says leave the y alone, take the derivative of cosine, which is minus sine, technically times the derivative of x, which is 1, plus the derivative of y, which is 1 dy dx, and then leave the cosine alone. Okay, so hopefully you're kind of, sort of, I mean, this was a lot of steps. Product rule, left the first one alone, the derivative of the second one. And I mean, you could write more steps. You could say, leave that alone, x times, then write derivative of that one, plus leave this alone times the derivative of x, which is what I did here. And so this piece here, I left y alone times the derivative of cosine, which is minus sine, cosine of x, so minus sine of x. Here I took derivative of y, which is 1 dy dx, and then left cosine alone. Now you're pretty much home free. This is now algebra time. And you're going to see I'm going to do the same thing. This is very similar to the other one. I'm going to distribute that. So I'm going to have, I'm not going to write the dy dx again. I'm going to have that go away. 4x cosine 4x plus 7y. So that's just that times that piece. That's what I thought. And then plus this piece times this piece, so 7x dy dx cosine 4x plus 7y. And if you think this is bad, wait till Cal 2. I helped somebody with a problem and it took us 3 pages. Plus, I'm not going to do anything with that. I'll get rid of the 1. Sine 4x plus 7y. Unfortunately, going to another line. All I'm going to do there is just distribute that. And there's that. The only reason I did that is because now I want to put everything with a dy dx on one side and everything without a dy dx on the other side. So I'm going to have 7x dy dx cosine of 4x plus 7y. Chunking this one to the other side, so minus dy dx cosine of x equals, I really don't feel like writing all this crap. So this went over there, so minus 4x cosine 4x. Think I can get it to fit? Sure, I can shrink this till y'all can't read it. So what else I got? I got a minus sine 4x plus 7y. And can you still read it? And then a minus y sine of x. So in other words, everything that did not have a dy dx went to the right side, and everything that had a dy dx stayed on the left side. Same thing as we did last time. We factor out a dy dx because that's what we're solving for. So we get 7x cosine 4x plus 7y minus cosine of x equals all that junk up there. I don't want to write all that again. And then finally, your last step is you divide both sides by this junk in here. So dy dx equals minus 4x cosine 4, if I can read my handwriting, 7y minus sine 4x plus 7y minus y sine x all over 7x cosine 4x plus 7y minus cosine of x. And my math lab says, Maybe my math lab has a problem with negative signs. What my math lab did was factor out a -1 in all terms. So I guess I'll write it again. I'm getting tired of writing this problem. So everything negative becomes positive. 4x plus 7y plus sine 4x plus 7y plus y, exactly. All over, let's chunk the cosine out front because it came positive. And there you go. So it kind of was just like the last problem. And so you're still doing the same thing. You're just going through and you're finding derivatives. You're getting all the dy dx's on one side. You're factoring out a dy dx. Typically, whatever this piece is that's left, you're dividing. And then you're trying to see, again, it's nice because this was a my math lab problem. So then you're trying to see how my math lab wants it, basically. And so this is why I said I would do your multiple choice problems, meaning I will write the problems this next test, because that's how I would have left the answer, and that's how you would see it. I would leave it the way I would think you guys would leave it. All right, so that's a couple of those. Believe it or not, I actually know where we left off last class. Let me stop recording.